So in this session of m squared m cubed or 2, Mrs. M's Math to the Masses in a minute or two, we're going to talk about examples of conditional probability. Let's first remember that if you're given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. So the notation is probability, there's our P, B given A. That slash is read as given. Here it says read as the probability of B given A. And the conditional probability formula is here noted as your uppercase P in parenthesis B given A, and it will equal the probability in the numerator of both over the probability of A, since that was the given. So we'll move through and start looking at examples. If Mitchell drew a card from a deck, a standard deck of playing cards, what is the probability that he drew a queen given that the card was red? Well, out of a deck of 52 cards, half of them are red. So your denominator is 26, but there's only 2 red queens. So then you would reduce this to 1 over 13, which equals 0.08, or an 8% chance of that happening. In our next example, it reads, a number from 1 to 100 is randomly selected. What is the probability that it is an odd number given that it is less than 50? So even though we have 1 to 100, we're only talking in the denominator about the ones less than 50. So there are 49 values less than 50. And since they just want us to look at odd, that would be 25 over 49. That is already reduced. There's no way to reduce it. But then when you switch it to a decimal, you would get 0.510, depending on how far out you want to go. When you multiply by 100, you're going to have about a 51% chance of this occurring. Again, this is conditional probability. So in this next example, we're going to look at 62 people who take yoga class at a gym. 48 of them take spinning. But then you have your super athletes doing both. 15 people do both. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. So we know we need our probability of spin as our denominator. And our numerator is those that do both. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. So our total spin is 48 people. And our total that do both, the probability of yoga and spin, was 15. So that becomes 5 over 16, which equals 0.31, which is about a 31% chance. We have one more example we'd like to work through, and it concerns 30 students in Mr. Smith's math class. 13 are athletes and 9 are in band. So let's kind of color code this a little bit. Here's our athletes. These are in band. But of course we always have our ones that do both. If one student is chosen at random, find the probability that this student is in band. So our numerator will definitely be about band. Knowing that they are not an athlete. So we're going to calculate non-athletes. I said it's always just a fraction we're setting up. Let's see, we'll put this like that. We'll make this a big P out here. These are the conditions. Probability of band, not athlete. Okay. So we're going to go with you had 9 total that are in band, but you have to subtract the 3 athletes to get 2 non-athletes. And you have 30 total in the class, but again, you're doing this out of total non-athletes, so you have to take away the 13 that are athletes. I really should have put this parenthesis here, not necessarily around the P, but we'll go with it. Okay, so when you bring this math over, you end up with 6 over 17, which is 0.35, which is a 35% chance. Those are examples of conditional probability.